In this video, I'm going to go through the YTSS Prelim 2022, the last question, question 12Or. So this is the easier question among the two questions that you get to choose. So you have a toaster, and in the toaster, you will notice that it is metal casing. So once you see metal casing, automatically you should think of earthing, right? And you can see that the switch is also here. So because of that, when you answer part A, state one other electrical feature that you see in figure 12.2, you cannot tell me it is the switch, right? I'm looking out for answers like the earth wire being connected to the metal casing. Now, some of you actually answer earth wire in the plug. Actually, the fuse is in the plug. So actually, if you want to look at the fuse, this is where the fuse is right at the plug, right? The earth wire is not in the plug. The earth wire is connected from the casing through the cable to the earth terminal, which is this guy over here. Yeah. Explain how a fuse protect from an electrical fault. I just want to highlight to you that electrical fault cannot be prevented. This thing is an accident, so it cannot be prevented. We can only react to it. So a fuse basically reacts to the electrical fault and therefore prevent a fire from happening, right? Electrical fault can be short circuit due to wear and tear, things like that. So down here, those of you who lose mark, maybe you didn't tell me what is considered as a large current. You need to be able to tell me that you are relating it to the fuse rating. Some of you are still making the mistake. The fuse doesn't melt. It's the fuse wire that melt. If you want to talk about the fuse blow. The fuse wire melt, right? Then there are some of you who still do not know how to describe a circuit. You are confused between short circuit and open circuit. So what you do is that when the fuse wire melt, the circuit basically opens, right? And when the fuse blow, what happens is that it protects the toaster from the high current, or it protects it from overheating. Yeah. Down here for C part 1, most of you got it correct, so I'm not going to go through it in detail. You can read about it. For part 2, the same thing. I think it is about phrasing. Most of you picked the correct fuse rating, which is 5 ampere. For the 3 ampere, most of you doesn't have any issue explaining yourself. Maybe you just need to know how to phrase it, normal condition. For the 13 ampere, why is it bad? Is because you won't be able to protect the toaster from a high current like 10 ampere, which is already like 3 times more than the normal operating current. So you need to tell me very clearly that the toaster will be damaged before the fuse blow. Yeah. So as long as you give me something like that, you will be able to get the full 2 marks. Yeah. So the mark distribution is first mark for picking the right fuse rating. Then the next mark goes to why the other 2 is bad. For part D, I am still getting some of you who doesn't know how to calculate the thing. You all got 20,000, 50,000 for running a toaster for 15 minutes, for making breakfast for a month. How can you pay that much? So I can tell you with a lot of conviction, this question is going to come out in your Cambridge O level. So get it clear, understand how to solve this, because it is going to cost you mark in your O level. Yeah, and it is actually very, very simple, right? Because in practical electricity, electrical energy is sold in kWh. You need to know how to get this value, and it is so straightforward, right? So they tell you that the toaster actually has a power rating of 850. Turn this 850W into kW by dividing it by 1,000, right? Just divide the W by 1,000, right? You will get the kW, right? So now you found this part. How long has it been using? Yeah, you have the duration. So turn this duration into hours, right? And you will be able to get this part. So once you got the kW from the power rating and you got the duration in hours, you just need to multiply them like that. Once you multiply them, you get the amount of energy used in kWh. And then now you know that every 1 kWh is 65 cents, and you can find out that the total cost is $4.14. Now for the last question, which most of you got it wrong, is because you are still using the same power rating, which is 850, when the voltage has been changed to 480V. So you need to remember that when your voltage, input voltage has changed, your output power must change as well, right? It is no longer 850W. So how do you find the new W? You need to realize that whether it is old setting or new setting, the resistance of the toaster is going to be constant, whether you have a high input voltage or low input voltage. So use the old information with a power rating of 850 when you supply 240V, and you go and work out what is the resistance of the toaster. Once you know the resistance of the toaster, you can then now work out what is the new current that will flow through when you supply a new voltage. So use your V equals to IR. This is the new input voltage 480. You can see that they are different over here. Look at this value and this value, right? The old voltage is 240 and you will get an old power 850. With the new voltage of 480, you would expect your current to be different. So this resistance over here come from here. The resistance of the toaster doesn't change unless you change some wiring or whatsoever. So you will be able to work out that the new operating current will be 7.1 when you supply a new voltage of 480. And as a result, the fuse you chose in C part 1, which is 5 ampere, will blow. So I hope that with this, you would understand this question, which mainly focus on practical electricity. If you have question, quickly clear it with me.